Kim Arcand, our friend, you have your stars on.
I do.
Yay, Kim Arcand. So I wore my sparkles today to represent
good.
stars.
Great.
Okay,
so we
cool.
match.
So you have the actual star. I didn't have any stars shirt, so I wore my sparkles today. If anyone was wondering what that was. So Kimberly Arcand is the visualization lead for NASA's Chandra X-ray Observatory. And so today we're talking a little bit about some of her work that she's done. Welcome back to the Navigant Credit Union Broadcast Center. We're going to talk a little bit about Chandra, and then we're going to talk a little bit about the work that you've done with exploding stars.
My favorite.
Always fun to talk about. So let's start off with that. There are new ways that we can experience these exploding stars. We've talked a little bit about it before, but let's really dive into it. The work that you've done with these exploding stars, we can really experience them in a new way through virtual technology, through virtual reality, through new technology. And you're going to give a presentation at Brown on Wednesday. Talk to us a little bit about what this will be like for you.
Well, hopefully if we don't get snowed out.
We're just going to say it's happening.
All right, good. So I'm going to be talking about how we take data of these exploding stars and essentially understand them in really interesting ways for people of all different interest levels, expertise levels, and abilities. So the idea is you can take something like Cassiopeia A, which is a star that's exploded. It's about 10,000 light years away from us. 10,000 times 10 trillion kilometers gives you the distance of what a light year is. And look at that object in a totally new way and understand how it exploded and how it's expanding. So we've been able to take that information and create 3D prints, and then we've evolved the technology more to be able to create a virtual reality experience around it. So I'm going to step people through how we've done that using real data from NASA observatories, and in the way that we've been able to take that information and create a very interesting multimodal experience, both for experts and non-experts.
It's so fun. It's so
It is
fascinating.
fun.
So if people are headed to the event, it is Wednesday at 5 p.m. and we're saying it's happening,
Yes.
weather aside. Wednesday, 5 p.m. at, I believe it's Hazleton Commons School of Engineering at Brown University. So if people are headed, they can learn more about how you collected this data, and then how it was transferred into making it an immersive experience. Will people actually get the opportunity to put the headset on?
Yes, actually, I'm very excited. We are going to have one of our Oculus Rift headsets there, and it'll be attached to our laptop that's running the application for the virtual reality experience, so that we'll actually be able to zoom around and walk around amongst the stars, which is very, very cool, I promise.
Just having the opportunity to be able to be in the stars, in this universe that is light years away, it's outrageous to think about. Talk to me, how was this actually created? So this is data that, and we've talked a little bit about this before, but this was data that was gathered over a significant period of time.
Yes.
Once that data was created, what was the process that looked like to be able to make this immersive experience?
Well, it's quite a few steps. Cassiopeia A is a really famous example of a supernova remnant. So fortunately what that means is we have a lot of really good information on it. So we took information from different kinds of wavelengths. So we have X-ray data, we have infrared data, and we have optical data as well, visible light. And by combining that information, we're able to understand where stuff is in relationship to us. So the distance that things are and the velocity that they're either traveling away from us or towards us, wherever. So by being able to understand that velocity data, we can recreate essentially a 3D map of the data. And it uses the Doppler effect, which is the cool thing. So I think a lot of people are probably familiar with the Doppler effect.
Yeah.
You know, the ambulance that's going by, yes, it gets louder when it approaches, but also the pitch changes.
Wow.
So it's similar with light. It's like you're looking at the different pitch changes, the frequency changes of that light. So that's how we can create this 3D model, which we can then turn into a 3D print, or we can bring into the Brown's virtual reality lab and create a virtual reality experience.
So when you are headed to Kim's event, because of course you want to hear more about this,
Yeah.
and then you want to put the headset on and experience it, are we actually looking at this one example, or are we looking at something similar to it?
So we'll be looking at this exact example.
Okay.
This was the very first time we've ever been able to take data, real data, and create this actual experience. So we will also have an additional virtual reality experience there as well, which is the Galactic Center. So at the center of the Milky Way, there's this really supermassive black hole. It's called Sagittarius A star, and we have a 360-degree video of the various kinds of stars that are around it, what are called Wolf-Rayet stars, and kind of what's happening to them as material accretes near the black hole. So there are a couple experiences like that we'll have on hand.
Awesome.
Yeah.
I want to see inside a black hole.
I know, right? Who doesn't? Well, so what's interesting about that second experience is that you're at the perspective of the black hole, looking out. So you get to see from the black hole what's happening to the stars around you, which I think is just so cool, right?
What?
Yeah, that's really fun.
Incredible.
Yeah, it is.
Incredible. This is what I was saying. This is kind of a STEAM-driven show today. We're
Yeah,
talking about
it's great.
art. We're talking about science, technology. We're talking about all these things. Okay, so we're looking at this very specific data. We're talking about very specific experiences. Now, are you working on things down the road? Are we looking at multiple experiences available in the future? Is this just one set of future experiences in galaxies far, far away?
Yes, that's a great question. I like the Star Wars reference, of course. So the whole idea is as we learn more about how to process our data in this interesting way, and as new tools, new software, new technology is created, we have the opportunity to do this for more objects. So sort of my grand goal is to map different parts of stellar evolution, how stars evolve and change over time, by using these 3D technologies and these virtual reality technologies, so that you can see from a very first-hand perspective how the stars change and evolve and why we care. We have our own star, of course, we care that way. But we also care about exploded stars because they are the seeds for future life, future generations of material and stuff that comes from that explosion.
And this has been kind of your baby, your star baby over the course of a long time.
My star baby.
Your star baby. I don't want to take away your family.
Right.
So your star baby, working with this data for a significant amount of time. What is it just like for you to be able to see this data work its way through into a process where now you can actually experience it in this form?
Yeah, actually, it's one of the great privileges, I think, of what I've been able to do with my job. Working for NASA's Chandra Observatory is I was there on the ground when the observatory first launched back in 1999.
Oh, wow.
And one of the very first objects Chandra looked at was Cassiopeia A. And I remember looking at that image, and I worked on the data. So back in 1999, I was working on that data to create the first two-dimensional image of this exploded star from the Chandra Observatory. So to see it change from those few photons, those few bits of light, that we got way back, and to now to be able to have this experience where you're walking inside it, it's tremendously powerful. It's got such an impact.
That's right. It's overwhelming. And I get nerdy. I'm like geeking out talking about it. So,
well, you're in the right place with me.
So. Okay, good. And that's what I think. I think it's so important to talk about this kind of stuff and try to get other people excited about it. And you and I have had these conversations, and I love being able to bring in scientists to be able to get other people excited about it. Because I think that's what's so significant, to get our future STEM leaders to be able to get them to make other people excited about it. So we have those people in the future that can work on this kind of stuff, right?
Oh, absolutely. I always hope that, I try to spend a lot of my time going to give talks and going to libraries and going into schools to meet kids because, well, for one, I just love doing that, but also I really do hope that it helps get somebody else excited about this type of work. And who knows if we'll create, new generations of astronomers necessarily, but just people that are interested in this type of work and why we care about it. So.
Well, and I think too, people probably didn't realize that it was a possibility to take data from 1999.
Sure.
You probably, maybe you did.
I did, not from this extent, no.
To take that and to be able to make a virtually possible experience. There's so many different. You're in augmented reality, so, and the specifications from that are enormous. So that, again, Kim's talk is happening Wednesday, 5 o'clock at Brown University. And then a couple other people that have been involved in this process, too.
Yep.
They're jumping in on the conversation, right?
Yes. So I, again, have been so grateful to have experts from Brown University, because the whole reason this project started, the virtual reality prospect, is because I walked into their lab one day with a school group that I was hanging out with and saw this great 3D experience. And it was like dinosaur footprints.
Oh, cool.
I think a heart. And I'm like, well, why can't we take my 3D data and put it in here too? And it was such an amazing thing. So I have to give major props to Tom Skiros and also Elaine Jiang. Both of them have been amazing to work with on the VR version.
And it worked.
It worked. It was great.
It worked.
Yeah.
It didn't not work.
Yes, it worked.
That's so cool. Kudos to them for making it happen. So Chandra is turning 20 here pretty soon. So before we let you go, let's talk a little bit about the significance of that and the significance of really what X-ray technology has done over the course of the past 20 or so years. So a lot of us might think of X-ray technology of, oh, we go in and we get an X-ray when our arm's broken or something like that. But X-ray technology has really helped in the discovery of astronomers over the course of history. Can we talk a little bit about that and why it's impactful?
Sure. Well, so X-ray astronomy really didn't get off the ground until like the 1960s. And there were some very basic spacecraft that were made early on. But it's taken a lot of work to get to where we are today with the Chandra Observatory. Huge leaps and bounds have been made in just a handful of decades versus, say, optical astronomy, where people have been using optical light for information of the universe for a long time. But technologically, it was so challenging to do this type of work. They had to create, just to make the Chandra Observatory, they had to create a lot of very specific applications and techniques in order to make such a powerful X-ray telescope. And so for me, as the Chandra's 20th anniversary is coming up, one of the really fun things to think about is that, any given month or year in your life, if you get an MRI, MRI technology has been improved and made machines like easier and lower maintenance because of X-ray spacecraft technology. Scanning luggage at the airport has become easier due to X-ray spacecraft technology. I get mammograms every 6 months because I have a risk factor. Those mammograms are now lower dose and higher resolution imaging because of spacecraft like the Chandra Observatory, and the list goes on and on. It's, food quality control, looking for safety and other types of issues in like airport equipment and automobile tires, how we process sort of the smaller scale of things, molecular biology samples. It's amazing. Like, there's this huge list of stuff that never, I think, would people have expected the development of just a couple X-ray telescopes would lead to. So I love to talk about that and think about that, because though astronomy is great in its own right, I think it's an important question to ask ourselves and try to find the answers to. It's also really nice to see that there are some fascinating real-world applications that result out of that high-end technology that we have to create to answer those questions.
Well, it's incredible to think that using such highly valuable scientific technology could be used in everyday practical stuff.
Right.
Like, who would have thought that
Right.
it would have led to that, right?
Exactly. And this is something that I've, having worked on Chandra for so long, I didn't know until recently, maybe like late last year, that all these things had been improved because of the X-ray telescope that I work for every day.
That's pretty neat.
So having that connection to, things that I go through in my life and how they've been made better by this one spacecraft, not to mention the others, it's really incredible. It's a great feeling to have,
It is. So we can all thank Kim.
Not me. The engineers, definitely not me.
We can say thank if you see her. Just
All
say,
right, sure.
Thanks, and then you can pass it along.
I'll take it, but
You can pass it along.
Sure.
To all the folks there, because I know probably a lot of people have had several things you've talked about, MRIs,
Yeah.
and we know that those can always be fun when you're sitting in one of those. So making it a little less uncomfortable. Let's talk a little bit about before we have you go as well. Let's talk a little bit about Magnitude, your book that came out not too long ago.
Yeah.
It's always fun to talk about this. I read an article by your co-author, Megan.
Megan Wansky.
Wansky.
Yeah.
Forgive me, Megan. I'm sorry if I pronounce your
She
last
doesn't
name.
mind.
Forgive me. She lives in the Seattle area,
Yes.
so
Yes.
I love you for that reason, just alone. I read an article that she put out before the Olympics went out, talking about comparing the scale because your book Magnitude is all about comparing the scale of things in the universe, talking about athletes competing in the Winter Olympics and comparing different scale, and I just thought that was fascinating. Talk to me just a little bit about why it was fun for you to be able to write that book and put things in perspective.
Well, so I love being able to make connections to every day. Obviously, we just talked a whole bunch about MRIs and things like that, right? So, I mean, the whole idea of physics and that it's some very out there sort of thing or abstract thing, I think can make people feel disconnected to it. But physics, it's everywhere you go, it's every day, it's all the things that you do. So being able to make really interesting connections to the sports that we enjoy, whether it's Olympics or something else, football or who knows, or, you know, trips to the doctors, which are, I guess, less fun topics. I think it's really useful to be able to do that because it puts things in terms that are relatable. You know, so you can talk about how fast a dead star, a neutron star, is spinning. And if you can compare that to how fast an ice skater can spin, it's just easier to understand the magnitudes of difference between those two things, which seem so different, you know? And for the record, the dead star does spin faster, which is amazing because it's like the size of a city. So the fact that they spin that fast is pretty cool.
It's so fun to be able to think about those, and so incredibly mind-baffling. But you being able to put some of that kind of stuff in perspective, the two of you being able to compile that into a book, and then picking out just different examples, because all eyes were on the Olympics, and being able to say, okay, here's a dead star spinning at this rate, and I'm like, what?
Yeah, right, exactly. Yeah, it's fun, because you can take like a weird sport like curling, which I still don't get. I know people love it, but I don't get it. And talk about the mass of that curling stone, I think they're called, whatever that.
We'll go with that.
Sure, that thing. And talk about how that compares with other types of masses. So it's just a fun way to be able to talk about the physics of the universe and how it relates even on normal scales of, you know, people size. Everything's connected, here, there, and everywhere.
And then it all gets us talking about science,
Which is great.
which is always a good thing. Which I think it's always
Yeah.
a good thing too. Kim, thank you so much for joining us today. If you're interested, you can go check out her speech, or well, her presentation, I should say, and then go walk through the star yourself.
Yeah, it'll be fun.
Why not? So please check that out. I'll have a link on our webpage, GoLocalProv.com, of course, and for more information on that, you can always check out her website, which I'll have a link to as well. So hang tight as we get set up here for our next guest on Go Local Live. We're continuing this theme here on live. Hang tight. Awesome, Kim. Thank you.